Okay, so we're measuring where the x's are at. So let's talk about this angle first right here in the middle of this first one. So how big is this angle right here?
103.
Okay. Yeah, y'all have those bigger ones. I do have some small ones. I could not find them. So the small ones are easier because it gets right out there to it. It's closer to, I mean, it's around 100. Okay, let me put this other one on here. We'll see. Okay, so it's really close to 100, okay? We're going to go with 100 because it hits right there. All right, so that angle is 100 degrees. Okay, guys, need you to listen, please. This angle is right at 100 degrees right here. Now, based off of this central angle is 100. How many degrees is this arc out here?
100.
This arc is 100 degrees. The arc and the central angle are always the same. So today what we're going to start talking about is inscribed angles. Okay? This is a central angle. So let me just put that right here. This is a central angle. For obvious reasons, it's an angle in the center of the circle. This one right here is what we call an inscribed angle. Okay? It's an inscribed angle. What that means is that the angle starts from the edge of the circle. Okay? So the vertex of this angle is going to be at the edge of the circle. That's what an inscribed angle is. All right, now when we measure that angle, how big is that angle? Okay, it's right at 50 degrees. Let me use this other one. Oops. Okay, so you can see it's right at 50 degrees. Okay, there is a correlation. Okay, there is a correlation between the central angle right here and the inscribed angle.
It's half.
Okay, how does this number compare to this number?
1/2.
It is 1/2. Okay, and what we're going to see is this is not by coincidence. Okay, this is the way inscribed angles work. The inscribed angle is always going to be half of the arc that it creates. Okay? Like the central angle was 100, the arc is 100 degrees, the inscribed angle is half of that. So the inscribed angle is always going to be half of whatever its arc is out here. So let's look at that on a couple more of these real quick. So on this one, how big is this central angle right here?
54.
Looks like it's pretty much like 60 degrees. Okay? And again, this is harder to measure with these bigger protractors because you really need to extend the lines and all that, but it's about 60. Okay? So if this angle is 60, how many degrees do you think this arc is right here? It's 60. Okay? And now you probably have already measured this, but if you hadn't, what would you guess this angle is going to be?
30.
It's going to be 30. Okay, so let's measure and see. And yep, you can see it's 30 degrees. All right, let's look at this one right here. Now, before I talk about how big this angle is down here, what type of line is this that's going across here?
180.
Well, what do we call this type of a line?
Diameter.
It's a diameter. Okay, good. Now, we are getting to what you're talking about. So with this diameter drawn, how many degrees is this arc right here?
180.
This arc is 180 degrees. Yep. So based off of what we talked about up here, where the arc is 100, this is 50, this arc is 60, this angle is 30. If this arc is 180, how big do you think this angle should be?
90.
Should be 90. It should be half of that. And let's just check and see. And yep, sure enough, it is 90 degrees. So that's the main thing to get from today is the inscribed angle. Oh, this thing's lagging so bad. The inscribed angle is always half of its what they say is an intercepted arc. Okay? So this inscribed angle is going to make an arc. It's always going to be half of it. All right, let's think about this situation right here. Okay, before we measure these, I want to notice what's going on here. All right, so this angle opens up to this arc right here. Okay, so this angle opens up to this arc. And notice this angle opens up to the same arc. So just using common sense, what do you think is going to be true of two angles that open up to the same arc?
They're congruent.
They should be congruent. So let's measure them and see real quick. So this one is about 38 or so. Okay. And then this one right here, better be pretty close to the same thing. Yep, you can see it's 38. So obviously two angles like this opening to the same arc are going to be congruent to each other. Two angles opening to the same arc should be congruent. That's just pretty much the common sense. Okay, the last thing I want to measure here is this. Okay, this angle right here, again, this is what we call an inscribed angle. Okay, it's an angle where the vertex is on the edge of the circle. So here we have 4 inscribed angles. So inside of this circle, what shape do we have? Well, to be a trapezoid, these two sides would have to be parallel, and they don't look like they are exactly. So in general, this is a quadrilateral. So this is a quadrilateral that's inscribed in a circle. Okay, this quadrilateral is inscribed in this circle. So what I want to do is I want to measure these 4 angles real quick, and I want to see something going on here. All right. So how big? Let me do it like this. Get it better. So about how big is that angle right there? Let me just zoom in. How big does that look? Just looking up here on mine, how big does that angle look? 102, 103, about 103, 104. We'll go with 103, I think. Okay. So we'll say that angle right there is 103. Now let's measure this angle. Okay, how big is that one? Yeah, I think we're going to go with 65. Yeah, when I move that even closer, that gets even better. That's about 65 degrees. All right. Let's measure this angle. Sorry, let me get that. Yep, it's right at 77 degrees once I get everything all lined up. All right, and then this last one right here, let me do it like this. What does that look like? About 115. All right, get this all the way back around here. About 115. Okay. Now, since this is a quadrilateral, if I were to add these 4 numbers up, what do you think they would add up to? They would add up to 360, okay? But there's another thing that's going on inside of here. See if you can figure out what's going on. Just looking at the numbers, thinking about those numbers together.
They correlate with one of the angles.
Okay. There's 2 pairs of angles up here that something's true with these 2 pairs. Okay, which ones?
Well, the 103, they're not consecutive. 77 and
Okay, good. So if you think about it, 115 with 65, what does that add up to? That adds up to 180 degrees. Okay, if you take 103 and add it to 77, what does that add up to? 180 degrees. This again is not by coincidence. If you inscribe a quadrilateral inside of a circle, the opposite angles are always supplementary. So this angle and this angle will always add up to 180. This angle and this angle will always add up to 180. Okay, so what we've done is basically kind of looked at all the stuff we're going to need for our notes today. So on the notes page right here, the first thing is this. This is really the most important thing, is as it says right here that angle DEF, which DEF is this angle right here, it says is equal to half of the measure of arc DF. Okay? That's exactly what we just talked about. This inscribed angle is always going to be half of this arc. Okay, so on number 1, it asks for the measurement of arc AC. So we're looking for the measurement of arc AC. So the inscribed angle is 36. So what's that arc going to be? It is going to be what? 72. The angle is half of the arc. So I'm just thinking, all right, 36 is half of what? So what's the easy way to get from the angle to the arc then? Yeah, just multiply it by 2. Multiply it by 2. Oops. Okay, number 2. All right, the arc LK is 62 degrees, and we're looking for angle N. So remember, the angle is half of the arc. So when I know the arc going back to the angle, what am I going to do? Divide by 2, which, what is that going to give me? 31 degrees. All right, number 3 asks for the measurement of arc QSR, which QSR is from here to here. And so the angle is 113. So the angle is half of the arc. So what's that arc going to be? 226. Yep, just that times 2. All right, number 1, how big is angle A going to be? It's going to be 45. Half of the arc. How big is angle A going to be on this one? It's 25. On this one, what's the measurement of arc BC? It's going to be 80. Okay, do those last 3 real quick. So number 4, how big is arc BC? 170. It's just double that angle. Okay, on number 5, it asks for the measurement of angle BOC. Well, how big is arc BC first? Is 110, so how big is that angle then? 110. Because the central angle and its arc are always congruent. All right, and then on this one, how big is angle A? It's going to be 45. That angle is 90, this arc is 90, the angle is half of that. Okay, so pretty basic there, but that's a concept you definitely need to get. The inscribed angle is half of its arc. All right. Okay, on the back, this says to find, first of all, to find angle U, which is right here. Well, notice that angle U and angle V both open to the same arc. So we just talked about this. If two angles open to the same arc, what's true of these two angles? Congruent. So how big is angle U? It's got to be 30 degrees, just like angle V. These two are going to be congruent. See, angle V is 30 degrees. Now, the next one says find the measurement of angle T. So notice here that angle T and angle W open up to the same arc UV. Since they open to the same arc, what's true of those two angles? They're congruent. So we're going to set them equal, solve for x, and then plug that back in. So 3x plus 4 equals 2x plus 9. Just setting the measurements of these two angles equal to each other since they're equal. Subtract 2x. X plus 4 equals 9, minus 4, x equals 5. And this says find the measurement of angle T, so I'm going to take this 5 and plug it in right there. 3 times 5, yep, is 15, plus 4 would be 19 degrees. Okay, number 6. Find the measurement of angle A real quick. Work that one out real quick. So how big is angle A then? Is what? 58, yes. Those two are equal. Angle A and angle D are congruent, so we set them equal. 6y minus 2 equals 5y plus 8. Solve for y equals 10. Take that 10, plug it back in right there. 6 times 10 is 60, minus 2 is 58. All right. Pretty simple there. All right, let's drop down to this next group right here. All right, so find each one. So first of all, we're going to find the value of x. All right, I know how big angle W is, and I know how big angle X is, basically, but I don't know how big angle Y is right now. But how many degrees is this arc right here? 180. So if that arc is 180, how big is this inscribed angle down here? Yeah, it's 90. It's going to be half of that 180. Okay. So now I know that angle is 90. And the reason I need that is this, is the way I'm going to find x is, what do the three angles of any triangle add up to? 180. So what I'm going to do is this, is I'm going to go x plus 12 plus 90 plus x equals 180. All I did was just take these three angles, x plus 12, this 90-degree angle, this angle x, add them up to equal 180. All right. Combine like terms. So we're going to have 2x, 102 equals 180 minus 102. 2x equals 78, divide by 2, x equals what? So x equals 39. And then it says the next thing is to find angle W. I'm going to take 39, plug it in right there. 39 plus 12 is what? 51. Okay, solve for x on number 3 there real quick. Okay, so how big is angle S?
90.
It's 90. So 2x plus 90 plus 4x minus 6 equals 180. 2x, 90, 4x minus 6. Yep, okay. So combining like terms, we're going to get 6x, and then we're going to get 84 equals 180 minus 84, 6x equals 96 divided by 6. So what does x equal? X equals 16. And then to find angle T, I'm going to take this 16 and plug it right there. 4 times 16 is 64 minus 6 is what? 58. Okay, then on the last one down here. So remember we talked about this. When you inscribe a quadrilateral, what's true of this? Okay, all of these equal 360. We could approach it that way, or what else? Okay, good. These two add up to equal 180, the opposite angles. And these two add up to equal 180. Okay? So we can set that up however, but actually that's not the way they did that. Because, okay, I did not write this problem, but if you set up like this, okay, no, I'm thinking wrong. Okay, so we're going to go 3x plus 75 equals 180. Okay, minus 75 on both sides. 3x equals 105 divided by 3. X equals 35. Yep. And then if you set up the other way, 2x plus 110 equals 180. So, I mean, you'd only have to do it one way, but subtract 110, 2x equals 70, x equals 35 that way also. Okay. So if x is 35, how big is angle R? It's got to be 105. Just plugging that in. And if x is 35, how big is angle S? 70, which I guess for that matter we didn't even really need that because obviously 75 plus 105 gives us 180 and 110 plus 70 gives us 180. Okay, on this one we are going to have to use this. Okay, so what's up with these two angles? They're supplementary, so 2x plus x plus 18 equals 180. So 3x plus 18 equals 180. Subtract 18, 3x equals 171.62. Divide by 3, it's going to be 554. So if x is 54, I'm going to take that 54 and plug it in right there for angle W. What's 54 plus 18? Is what? 72. And then these two opposite angles are supplementary. So on this one, 3y minus 7 plus 3y plus 1 equals 180. So 6y minus 6 equals 180. Combining like terms, add 6. 6y equals 186 divided by 6. And that's going to be 32. Oh, yeah, sorry, 31. All right, so now I'm going to take that 31 and plug it in up here for angle X. So 3 times 31 minus 7 is what? 86.